In the next few videos, we will be going through different types of functions and their properties. So to kickstart this, we will first go through the definition of functions as well as some basics in this topic. Simply put, a function is a rule where each input has a single output. We denote it like this: y is equal to f of x. F is our function, while x is our input or independent variable, and y is our output or our dependent variable. We can also say from what sets our input and outputs belong to. Another way to describe which sets are being mapped from and to is this notation. A is what we call the domain, the set of all possible x values. Meanwhile, B contains the range. The range is a set of all possible y or outputs. Note that the function range may only be a subset of B because it is limited to what the function can output. So to understand this, let's look at an example. So let's say we have our function f that maps from the real numbers to the real numbers, and the rule is to square the input. From our quadratics lesson previously, we would know that this graph is a convex parabola. And so the domain is just as given, the set of real numbers from -infinity to infinity. The range, however, is the set of non-negative numbers, since a squared number cannot be negative. So this, you'll also notice, is only a subset of the real numbers noted here. Okay. Let's look at another example. Y is equal to the function of x, which is the square root of x plus 2. Since the inside of a square root cannot be negative, we limit the domain to where x plus 2 is greater than 0, or in other words, x is greater than or equal to -2. Meanwhile, since functions can only map to one value per input, we'll limit the output to the positive root, and so the range would then be y is greater than or equal to 0. As you may expect, we can perform mathematical operations, plus, minus, times, divide, to functions. So let's suppose f and g are functions. We use the following notation to express these operations. Right? Note that the domain of these combined functions is the intersection of the domains of the individual functions. So for instance, the domain of f plus g would be the intersection of the domain of f and the domain of g. Note that it is slightly stricter for the f divided by g, since we also have to keep into account that the denominator cannot be 0. Another thing we can do with functions is to transform it. One of the easiest ways to observe this is by looking at how the function graph changes. So we can move it up, down, left, right, compress, and stretch it. So for this example, let's try and do some different transformations to this function over here, x squared minus 2x. So firstly, we can shift it horizontally by adding a constant k to x through this over here. And so through this, we can see as k decreases, becomes negative, it moves to the right. And as k increases, it moves to the left. Another thing we can do is shift it vertically by adding a constant to the entire function. So here, as we decrease, our function moves down, and as we increase, our function moves up. We can compress or stretch it in the horizontal direction by multiplying our x by a constant k. So here, as k increases, we see that our function kind of gets squished, When k is less than 1, it stretches out, and at 0, we just get a straight line. Also note that if k is negative, it will display similar behavior, except the function is also reflected along the y-axis. Similarly, to compress and stretch vertically, we would multiply the function by a constant. So here, we see as k increases, our graph stretches vertically, and as it gets less than 1, between 1 and 0, it compresses, and at 0, we get a straight line again. Also, in this case, when k becomes negative, it will also reflect along the x-axis. Finally, is if we change x to be the absolute value of x, we would disregard the left-hand side of the function and instead reflect the right side along the y-axis. And so that was our introduction to functions.